Hey guys.
Hi.
Maybe I'll mute you guys when you come in. All right, does anyone have questions about homework? Homework questions? Nope, so that's good then. So did any of you guys get the challenge problems on the homework? There were 2 challenge problems. Did anyone get those? No? Yeah, so those are pretty advanced problems.
Have you played Animal? Yeah.
Gavin's doing the Rubik's Cubes again.
Yeah, okay.
4x4.
Yeah.
Wow.
I need the parody out.
Wait, what?
To solve it.
All right, I'll wait.
I'm pretty sure. I know. Have any of you seen the launch of the new rocket ship?
All right. So for those of you that just came in, do you have questions about homework?
No.
Okay, then. I'll start at 8:01. At least here for me, 8:01. Okay, so let me share my screen now. Looks like it's on some problems. So this week on Prealgebra, square roots. Okay, so not that kind of square root, but math square roots. Okay, so maybe I'll wait just a minute more for people to come in. No one likes my joke. Okay, that's sad. That moment where no one likes the joke you made. Just not a good feeling. Okay. So square roots. So the topics we're going to talk about are, first, what are square roots? Not roots of a tree, but math square roots. And then we're going to talk about simplifying square roots. And then arithmetic with square roots. So that means addition, subtraction, multiplication, and division. Okay, so first of all, what are square roots? Well, let's first think about what is the square of a number? Like, what is 4 squared? 4 to the second power is 4 times 4, or 16. So the square root, by definition, is the opposite of squaring. So if I were to take the square root of 16, that undoes the square, which will make it 4. And the symbol we use for square roots is this little guy right here. It kind of looks like a house. And what we call this a radical. Okay? So that's how we would use square roots. So more examples of square roots are, well, the square root of 25, 5, right? Square root of 36, 6. So when we find the square root of a number, we ask ourselves, hey, if we take this number and we think about other numbers, what other number multiplied by itself will get to the number we have here? So in this case, for 25, we'll think, hey, what number times itself equals 25? 5, okay? So another way to visualize square roots is that taking the square root of something is the same thing as taking it to the 1/2 power. the square root of x is the same thing as x to the 1/2 power. Why is this true? Well, since square roots will undo squares, if I take x and I square it, and I take the square root of it, I have to, that undoes the square, and that's going to give me x again. Another way you could visualize this is x squared to the 1/2 power, right? Because taking the square root is the same thing as taking the 1/2 power. Using our exponent rules, this is x to the 2 times 1/2, or just x to the first, right? So the square root of a number is that number to the 1/2 power, okay? So you may be asking, hey, if I take the square root of 25, I only gave the positive 5. Isn't -5 also a square root of 25? Because -5 squared
Yeah.
is also 25. So the square root of 25 should also be -5 as well. So actually, for expressions like these, if I wanted to ask you, hey, simplify square root of 25, mathematicians from a long time ago, they made up this really dumb rule that you will only give the positive result, okay, for expressions. So expressions are things in which there's no equal sign. So if I asked you, hey, what is the same thing as this? Simplify it. Simplifying expressions, we only give the positive answer. We don't give the negative answer. On the other hand, if we're solving equations, if we have x as equal to the square root of 25, then in this case, x will equal both of -5 and 5. Okay? So when we solve equations with square roots, we include both answers. If we solve expressions, only use the positive answer. If you forget this rule, then mathematicians are going to say, hey, you're wrong. Okay? So you got to remember this rule such that for expressions, only give the positive result. For equations, give both the positive and the negative. Okay, so we can also do equations with square root. So if I had something like x squared equals 4, how do I solve for x? Well, what I can do here is taking the square root of something will cancel the square. Taking the square root of both sides is going to cancel that x squared that I have here. So all I have left is x equals the square root of 4. And since we're solving equations, we use x as equal to 2 or -2. And this can go the opposite direction as well. If I had the square root of x as equal to 5, I can square both sides to undo the square root. X equals 25. Okay? So this is how you would solve equations with square roots. And square roots work with, remember, the SADMAP rule with solving equations. Right? So remember, square roots are 1/2 powers. So that means square roots belong in the exponent category. So that's when you would use SADMAP here when solving equations. All right. So let's go on to some problems. If you get the answer, chat that to me. Wow, that was fast. So I'm getting a lot of answers here. So when you give your answer to me, can you write down which problem you're answering? This way I know which one I should check. If you guys need a review of SADMAP, SADMAP is the reverse order of operations, and that's how we're going to solve equations. Okay, so if there's plus x, then you would want to get rid of that first, because in the SADMAP rule, addition and subtraction comes first. Okay, so it's just the order in which you would solve equations. But don't reply to your text. That's because I have a lot of stuff that I need to answer. All right, how about one or 2 more minutes?
Has anyone else experienced a flash flood before?
No.
Okay, so one more response. So I'm going to go through these now. So the first one, these are just practices of your multiplication facts, right? What number times itself equals 144? 12, right? And then for 36, that will be 6, and the square root of 100 is 10. Okay, so this is just a review of your multiplication facts. So now, can I take the square root of 9? So, can I take the square root of 9? Well, if we ask what is the square root, that means we're asking what number times itself equals -9. If this number is positive, then a positive times a positive equals a positive. So it can't be -9. If I have a negative number, a negative times a negative is also a positive. So all perfect squares are positive. So it seems like I can't take the square root of -9. But actually, these math people, they were like, let's just say yes. So actually the square root of -9, this is the square root of 9 times the square root of -1. And the square root of -1, mathematicians just went ahead and said, hey, let's just pretend that we can do this. So they've unlocked something called imaginary numbers with a symbol I for the square root of -1. So you guys don't need to learn this right now, but in the modern world of mathematics, you can actually take the square root of negative numbers with imaginary numbers. It's just that these are not going to exist in real life. They're just imaginary. If I were to ask you the same question, maybe 100 years before, then no, you wouldn't be able to. But now, mathematicians have said, hey, let's just do this. And yeah, there are a lot of really fancy things going on with imaginary numbers, but you don't need to learn them right now. Okay? So now for the following square roots. For the first one, as we know, the square root will undo a square. So the square root and the square will cancel out and we'll have 12. The next one seems a little bit hard. So what can we do? We can remember that taking the square root of a number is raising it to the 1/2 power. This is 2 to the 10th to the 1/2 power. If we use our exponent rules, this is 2 to the 10 times 1/2 power, or 2 to the 5th, which is 32. Okay? Now 3 to the 8th, we can do the exact same thing. 3 to the 8th to the 1/2 power, or 3 to the 4th, which is 81. Okay? So the trick here was to take the square root as a 1/2 power. Now for 4 to the 5th power, it seems like we're stuck, right? If we take 4 to the 5th and we take the 1/2, we get 4 to the 2.5 power. That doesn't look good, right? But we can actually break down 4 into 2 squared. If we break down 4 into 2 squared, then we're going to have 2 squared to the 5th and taking the square root of that. Okay? So what is that? The square root of 2 to the 10th. 2 to the 10th to the 1/2 power, 2 to the 5th, or 32. Okay, so the trick here was to, two tricks actually. One was to turn square roots into 1/2 powers, and the other one was to turn 4 into 2 squared. Now for the equations. As you can see here, all my answers were positive. So for simplifying expressions, we always give the positive answer. But now we have to solve equations. So now let's use SADMAP here. We have an exponent and subtraction. Which one do we get rid of first? S, because S is in the beginning. So let's add 3 to both sides. So we're going to have x squared equals 25. Now we take the square root of both sides to cancel the square. We have x equal to both 5 and -5. When we solve equations, we have to give both values, okay? Now for 3x squared equals 75, this is a 3 times x squared. Okay, don't confuse this with 3x in parentheses squared, because in this case, the 3 is not being squared, okay? So now we have to get rid of this multiplication first, dividing by 3 on both sides. X squared equals 25 once again, so x equals 5 and -5. Now for the last one, to undo the square root, we take the square of both sides. Now we just have the square root's gone, so x minus 5 equals 3 squared, which is 9. So if we add 5 to both sides, x equals 14. Okay? Any questions? Alrighty. Now we have simplifying square roots. So what do I mean by simplifying square roots? Sometimes you're given a really wacky square root, like square root 12. Does anyone know what the square root of 12 is? Well, no, it doesn't give an integer value. It's not a perfect square like 25 or 16 or 7 or 49. It's not going to give some kind of easy, simple value. So how do we simplify this? Well, the first path to simplifying square roots is to prime factorize whatever's in the square root. So to prime factorize 12, that's 4 times 3. I'll break down 4 into 2 times 2, That's multiplied by 3, so that's 2 squared times 3. Okay, so we have to use our prime factorizing skills to prime factorize 12. Now we put 2 squared times 3 in the square root. So now we can see here that we have a perfect square inside the square root. And now the squared and the 2 is going to cancel with the square root. So what we can also do is we can divide this into 2 squared times the square root of 2 squared times the square root of 3. Okay? So now I have a perfect square here. These all cancel, so I'm just going to have a bare 2. That's being multiplied by the square root of 3, and that's how I would simplify the square root of 12. Okay, so basically you take the biggest, you take as many perfect squares out of this thing, and then you would take them out, and they would just be like that. So another example I could give is the square root of 48. Let's first prime factorize it. 6 times 8. The 6 turns into a 3 times 2. The 8 turns into 2 to the third. Now we have 3 times 2 to the fourth. Turning this into 3 times 2 to the fourth. As we can see here, 2 to the fourth is a perfect square. So we can split this apart to 2 to the fourth, and then 3, right? We can split it apart like that, and then we take the square root of this side. We have a perfect square that we can take the square root of. That's 2 to the fourth to the 1/2, right? Because taking the square root is the same thing as taking the 1/2 power. So this is just 2 squared times the square root of 3. 4 times the square root of 3. Okay? Does anyone have any questions about how we would simplify square roots? Because as you can see here, 4 times the square root of 3 is a lot simpler to look at than the square root of 48. Okay? Alrighty. We have these problems here. When you get your answer, chat that to me. The trick is take as many perfect squares out of whatever number you have here as possible. Take the perfect squares out of them. All right, I'll give you guys maybe 1 or 2 more minutes. All right, so you're not quite done yet. You can keep working on the problems you haven't done yet, but now I'm going to explain the first problem. So how would I simplify the square root of 24? Well, let's first prime factorize it. 24 is 4 times 6. So that's 2 times 2, which is 4, times 2 times 3, which is 6. So I'll have 2 to the third times 3, the square root of that. So if we take a first glance at this, hey, 2 to the third, that's not a perfect square. 3 to the first is not a perfect square either. So can we even simplify this? Well, if we break up 2 to the third into 2 squared times 2, then we're going to have a perfect square here. So if we break that apart, we're going to have 2 squared times the rest of it, which is 6. 2 times 3 is 6. And we just take the square root of here. So the squared and the square root are going to cancel out. So we just have a 2 times the square root of 6. Okay, so the trick here was to turn 2 to the third, break it up into 2 squared times 2. Okay? So now we have the square root of 50. Let's prime factorize this as well. That's 5 times 10, or 5 times 5 times 2. So this will be 5 squared times 2. 5 squared is a perfect square, so I'll break that apart. These cancel out, so I have 5 times the square root of 2. Now for the last one, square root of 72. Once again, I will prime factorize, which is 8 times 9. 8 is 2 to the third, 9 is 3 squared. This will be the square root of 2 to the third times 3 squared. We have a perfect square in here for 3, right? But we can also turn the 2 into a perfect square by breaking up 2 to the third power to 2 squared times 2. Right? So now we have 2 perfect squares that we can break apart. 2 squared times 3 squared. And all we have left is a lone 2. These are going to cancel out. These are going to cancel out. 2 times 3 times the square root of 2. 6 times the square root of 2. All right. Any questions? Alrighty. Now, square root 2 to the nearest 10th without a calculator. I know a lot of you have already memorized this, but how do you do it from scratch? How do you find what the square root of 2 is? Well, if you know your multiplication facts, you know that 14 squared is 196. That means 1.4 squared. Remember, all we need to do is add a decimal point so that there are 2 digits to the right of the decimal point now. 1.96. This number is really, really close to 2. So that means we can basically say that 1.4 is the square root of 2 to the nearest 10th. Okay? Now for the next one, how do we use the answer from here? Well, the first thing we can do is simplify the square root of 18. We can turn that into 9 times 2, or 3 squared times 2. So this is the same thing as 3 squared times 2. The 3 squared is a perfect square, so we can break that off. What do we have here? This will cancel out, so it's a 3 times the square root of 2. From the last problem, the square root of 2 is about 1.4. So we can write 1.4 times 3, 4.2. Okay? So we can, simplifying square roots can actually help us in problem solving. Okay? Does anyone have any questions? All right. Now, for the last thing we're going to cover today are arithmetic with square roots. As you know from what we've just done, if we have the square root of two things multiplying by each other, a times b, we can break this apart to the square root of a times the square root of b. And the same thing can go with division. We have a over b, all in the square root. We can split that up into the square root of a over the square root of b. And these can go in the opposite direction as well. Okay, so if you want to take maybe a screenshot or write this down in a notebook, I highly recommend that you do this. Okay, so you can split apart square roots and put them together if they're doing multiplication or division. But for addition and subtraction, you cannot. This is probably the biggest mistake that I have ever made. I've made most often is where I take the square root of a plus b and I split it apart into the square root of a plus the square root of b. This is not true. Don't do this. If I ask you, hey, what's the square root of 4 plus the square root of 25? We can't just combine them and turn them into, oh, the square root of 4 plus 25, square root 29. Because obviously the square root of 4 is 2. The square root of 25 is 5. And we get 7. 7's not the square root of 29. So addition's not going to work for square roots. And subtraction doesn't do that either. We can't just take subtraction and split it apart. Okay? The only addition and subtraction we can do is if the square root is the same. So what do I mean here? If I have 7 times the square root of 2 plus 5 times the square root of 2, in this case, I can add them. I have 7 square root 2's, 5 square root 2's. In total, I have 12 square root 2's. If you pretend square root 2's are apples, right? 7 apples plus 5 apples, 12 apples. And this also works based on a distributive property. We can distribute a 2 out of all of them. So we can only add these if they have the same number under the radical. They both have square root 2. If for some reason it was 7 square root 3 plus 5 square root 2, then we can't add these together. Okay? That's because we can't even use the distributive property here because they're not the same factor. Okay, so for multiplication and division, you can split them apart, put them together, whatever you want. But for addition and subtraction, you cannot do them unless there's the same number under the radical. Okay? Any questions about these? Okay. Let's do these questions. So once you get your answer, please chat that to me. Okay, so I'll give you guys one more minute because I want to leave some room for us to do the quizzes as well. All right, so for the first problem here, before we actually use any rules for simplifying square roots, what we want to do is we want to make sure that we can simplify the fraction here as much as we can. But right now it doesn't seem like we can, so let's just use the square root rule to split up this whole fraction into the square root of 49 over the square root of 4. Simplifying the top and the bottom individually, I'll have 7 over 2. Okay? Does anyone have questions? All right, for the next one, let's first make sure that we can simplify this fraction as much as we can before going on. So, can we simplify 63 over 28? Well, 63 is 7 times 9. 28 is 7 times 4. So, this can simplify it to the square root of 9 over 4. Okay? Now we can use our division rule for square roots. We can split it apart to the square root of 9 over the square root of 4. Just 3 over 2. Okay? So you got to make sure that you can simplify the fraction inside as much as you can before using any rule. Now for this one, we're going to first split this up. We'll take the 25, we'll put that in its own square root, and we'll take the x and put that in its own square root, because we're using multiplication here. So we can actually split these up. If we simplify this side, we'll have 5. On this side, the x squared will cancel out with the square root. We'll just have a normal x. And that's our answer, 5 times x. For the next one, we can't split it up to 4, the square root of 4 plus the square root of 9. We can't do that. That's illegal in mathematics. Okay? If you did this the wrong way, you would get 2 plus 3 equal to 5. But this is not true. If we were to simplify it inside first, this is just the square root of 4 plus 9, which is 13. The square root of 13. Okay? And the square root of 13 is nowhere near 5. 5 is the square root of 25. Okay? So you got to be really careful with addition and subtraction. You can't split it up. Now for the square root of 50 plus the square root of 32, we can't put these together and just make square root of 50 plus 32. That's not going to work. So can we even simplify this? Well, actually, let's first simplify these radicals, right? We can simplify each individual radical first. So how do we simplify square root 50? Well, that's the square root of 5 times 2, right? Because that's how I prime factorize it. Or the square root of 5 squared times 2. Now I can split this up into 5 squared and the square root of 2. These will cancel out. 5 root 2. Now, if I want to simplify the square root of 32, you can either split this up like 8 times 4, and then we'll get the square root of 2 to the third times 2 squared, or the square root of 2 to the fifth. And now we can divide up 2 to the fifth into a 2 to the fourth and a 2. And this guy cancels out, so we get 2 squared times the square root of 2. Or in other words, 4 times the square root of 2. We're adding these two things together now. They both have square root 2's in them, so we can actually add in this case. Because they both have square root 2's, so we can add these together. 4 square root 2's plus 5 square root 2's equals 9 square root 2's. All right? So we actually can simplify this. Simplifying radicals individually can help us problem solve. Okay? So does anyone have any questions with that one? So before you look at a problem and say, hey, I can't add those, try to simplify the radicals first. Now for the last problem, is this correct? Well, if you were to split it up incorrectly, well then yes, it would be correct. But you can't split it up like this. Addition doesn't work for these radicals. You can't split up an a squared plus b squared and split them up into two different radicals. You can't do that. All right? So this is incorrect. If we were to actually try this out with two numbers like 3 and 5, well, this would be 9 plus 25, or the square root of 34. Well, the square root of 34 is not 3 plus 5, right? So this is not going to work, okay? Alrighty, so now it is quizzes time. So let me get up the quizzes now. Let me first share my screen with you guys for the quizzes. Right here. So you guys see my screen? So go to joinmyquiz.com and go to 851682. Let me see if I can get the link in there.
Link. Thanks.
All right, I'll get the link in there. So you can click on that direct link to get into the quizzes, or you can go to joinmyquiz.com and enter in the code. So joinmyquiz.com, enter in the code 851682. All right, so I think last week our champion was Andrew with some kind of pie guy in second place. So let's see if it's going to change for this week. Look, there's the game code. You can never play a game of quizzes without someone having their name as the game code. You just can't. So I'll give you guys one more minute to get in. So while we're waiting, did any of you guys see the rocket launch today? So they launched the rocket from Florida with astronauts inside. Yeah, it was really cool.
Wait for what?
Elon Musk. Does everyone know Elon Musk?
Yeah.
Yeah, he made a rocket and he flew two people up into space.
But no, is his.
That's the company SpaceX, right? And Tesla.
Yep, I think he's the CEO of SpaceX, and he also makes cars too, and with his Tesla cars.
They drove to the launching site in Tesla.
In Teslas, yep. So I'm gonna start the game now.
Designed.
Good luck, guys, and have fun. So don't use a calculator for this. We want to keep it fair.
Yeah. Okay.
Oh, Ryan up already with the right answer. Oh, Oddog now in first place with 3 correct answers. Ryan now in first place. 4 correct answers. The top 3 all have all correct answers. Amy now in first place. Alright, so top 3 right now are Amy, Chameleon, and Sophia. Top 3 now, Amy, Otto, Chameleon. Alright, Sophia now in first place. Sophia with flawless game. See if the standings are going to change or anything. Whoa, I've never seen that before. Sophia and Jonathan have tied for first place. I've seen that happen before. Alright. Maybe about 30 more seconds in this game. And I'm gonna finish it. It looks like the top 5 for today's quizzes are Sophia and Jonathan tied for first place. Second place is Amy. Third place, Chameleon. Fourth place, I to the power of 2, which is -1. And we have in fifth place, Odd Up is in fifth place. Alright, I'm gonna end the game right here. Never seen 2 people tie for first place before, that's weird. Alright, here goes. Okay, so guess that ended pretty quickly. So congrats to everyone. Nice work, guys, today. And I'll see you next time. Thanks for coming. Bye.
Thank you.